So up next, we're going to get into something. So for this one is this terminology, and this terminology kind of always screw up with students. So the next thing we're going to be doing, we're going to be looking at least. So you kind of want to know what does at least mean. Anytime you see a problem that says at least means that's the minimum, but it could go beyond that minimum. So kind of think about a mathematical term, or mathematical notation will be this symbol right here. Could this symbol mean greater than or equal? So if I tell you x is greater than or equal to 5, that means we're looking for a number that the lowest it could be is 5, but it could be anything bigger than 5. And also kind of think about at least, if I tell you, like, say on the final, you need at least 100 points to pass the class. I'm telling you the minimum amount of points you need to pass the class is 100 points. But if you get anything higher than 100, you still will pass the course, because if you get 100 or above 100, you pass the course. So you do kind of want to get accustomed to at least, because there are going to be a bunch of questions that have at least. All right. Everybody good so far with the definition of at least? Cool. All right, so let's do some basic questions. So for this one, it says the event is that a person wrote at least a 2. So it says write down the event. So what we want to do, we want to write down the event that somebody wrote at least a 2. So that means the person must row a 2 or higher. So the person must row a 2 or higher in order for them to row at least a 2. So if you kind of remember the sample space for a die, all of the different outcomes is 1, 2, 3, 4, 5, and 6. So that's the sample space for when rolling a die. So for the right here for part B, we want to find the probability. So we're gonna say this is event, let's say A. So what we want to do, we want to list out all of the outcomes that give us at least a 2. So if we're rolling a die and the die only have 6 options, we can either roll a 2, oh, that was weird, a 3, a 4, a 5, and a 6. So how many outcome is that? So how many outcomes do we have that give us at least a 2? And you can just either write it down. Cool. Anthony. So you get 5. Everybody good so far where we got 5 outcome for this? All right. So if you look right here for part B, it says find the probability, or what is the probability? So we're going to find the probability that X is greater than or equal to 2. And that's equal to 5 outcome. And you divide it by how many total outcome you get or have. So if you look at the sample space has 6 outcomes. So you're going to divide this by 6. So if we do, oops, let's turn on the calculator. 5 divided by 6. You get 0.83. And will you put a bar right here? Because if you look at the 3, just repeats. So we could say, or 83 Cool. All right, and that's it for that first at least problem. Any question for that first problem? All right, so let's scroll on down.
How do you know if it's, oh, okay, 83%. I thought it was 0.83%. Okay, never mind. I figured it out.
Perfect. All right, cool. All right, so for this next one, it said the probability model to the bottom show the distribution of the number of movie a random person will see during the year. Most likely for this year, that should be way higher. All right, so if you look at the movies you see during the year, so it has 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, 8 or more. And then here are the probability for each one of those events. So if you look right here, it says, what is the probability a random person see at least one movie this year? So for this one, am I just gonna use one row, or do I need to get multiple row if I want at least one movie this year? So do I want to get multiple rows, or do I want to just get one row? So you can either shout it out, or you can put it in the chat.
Is it everything above 1, multiple?
Wait, could you repeat that? Wasn't paying attention.
All right, so for this one, you do want to get multiple rows, because if you look at it, not one of these rows satisfy it. You have to get multiple rows to satisfy it, because for this one, it says at least one. So that means we want to get the probability that x is greater than or equal to 1.
Okay.
So that means we want this row right here. You want this one.
Well, all of them, right?
Yeah,
Except
pretty much all of them. Cool. So everything highlighted in yellow, pretty much I want to add those up. But what you want to do in this case scenario, you want to use the complement rule. So the complement rule for at least one said that you want to get 1 minus the probability that x is equal to 0.
oh, makes sense.
Because if you look at it, which is the only row that I didn't highlight? Well, the only row I didn't highlight was 0. Cool. But why do you think I have a 1 right here?
Because if you add them all up, then it equals 1.
Perfect. So if I add all of these up, it should add up to 1. So that's where this 1 come from. It is saying the summation of all of the probabilities should add up to 1. Because if you remember, the one condition for the probability model says if you add up all the probability, it should always add up to 1. So for this one, we're going to do 1 minus the probability of 0, which is 0.01. And if you do that, you get 0.99.
99%.
Yeah, 99%. So that's it. Or 99%. All right, and that's it for A. Any question in regard to A? So let's go ahead and do B. Let me get the eraser. All right, so if you look at B, it says, what is the probability a random person see at least 5 movies this year? So for at least 5 movies, we want 5, we want 6, we want 7, we want 8 or more. So let me just scroll this down. And we're going to do probability that x is greater than or equal to 5. Everybody get why I selected those multiple rows? All right. So if you look at this case scenario, it doesn't really make sense to find the probability of these and then subtract it by 1. Technically, you'll be adding more than you have to. So I'm going to add these 4 numbers. So we'll say 0.189 plus 0.122 plus 0.079 plus 0.08. And I'm going to go ahead and go to my calculator and I'm going to do that. So we'll say 0.189 plus 0.122 plus 0.079 plus 0.08, and you get 47. All right. And that's it for B. Any question in regard to B? All right, so let's scroll on down. All right. So right now we're gonna be mixing up 2 concepts that we already learned today. So we're gonna be using the multiplication rule, but we're also gonna be using the at least rule that we just learned today. So we're gonna be using both of those concepts for this next problem. All right, so let's do this next problem. So for the next problem, it says the probability that a randomly selected student at West Los Angeles College transfer out rate is 17%.
Does not answer out.
According to the usnews.com/education. So we know the probability somebody transfer is 0.17. Everybody good so far with that one? All right, let's do A. So A says, what is the probability that a randomly selected student from West Los Angeles College does not transfer out? So we'll say probability. So I'm going to put T for transfer here to make it a little bit simpler. And for this one, we want them not to transfer out. So pretty much the complement, because you either transfer out or you don't transfer out. Cool. And once again, what we're going to do, we're going to use the complement rule, because if 17% transfer out, that means the rest of them don't transfer out. So we're going to say 1 minus 0.17, which is equal to 0.83. Any question in regard to how we got the 0.83?
Is this like actually true?
The percentage, yeah.
Wow, it's very low.
It is low.
I wonder if that's the same for like Santa Monica.
I don't know. You can probably go to that website. They'll probably tell you. I think that will give like all of the transfer rate for all colleges or community college.
Yeah, that'd be interesting to find out because they have the highest transfer rate.
Oh, they did? Yeah. Well, you could go there and you could kind of see what their transfer rate is. All right, so let's do B. So for B, it says, what is the probability that at least 1 of 5 randomly selected students from West Los Angeles College transfer out? All right. So this is where we're going to be mixing in the multiplication rule and at least. So for this one, how many randomly selected students or West Los Angeles College students are we trying to see they transfer out? So are we doing it for 1, 2, 3, 4, 5, 6, 7?
For 5.
Yeah, 5. Perfect. So we're doing this for 5 randomly selected students. So that's why we're doing the multiplication rule, because we're doing this for 5 students. So if you look right here, it says at least one. So when we're doing it for at least one, that means 1 of 5, but it could also be 2 of 5. It could also be 3 of 5. It could also be 4 of 5. And it could be also 5 of 5. So those are all of the possible options when we're looking for at least 5. So it could be 1 of the 5 transfer out, 2 of the 5 transfer out, 3 of the 5 transfer out, 4 of the 5, and 5 of the 5. But if you look at it, there's one outcome or there's one event that we're not looking for. What is that one outcome we're not looking for?
Why would they don't transfer out?
Cool. So that 0 of 5 transfer out. So instead of finding these 5 probability, what I'm going to go ahead and do, I'm going to just focus on finding the probability of this one. So we want to find the probability that if we have 5 students, none of them transfer out. So if we don't want them to transfer out, which of the 2 probabilities should we use? Should we use this one, which is we're going to label it as A? Or should I use this one, which we're going to label as B? So should I use 0.17 or 0.83?
0.83.
Cool. So we're going to use 0.83. So we're going to find the probability that X is equal to 0. And the reason why I'm putting 0 because we want none of them to transfer out. So we'll put 0.83. How many times should I put 0.83?
5
we,
times.
yeah, perfect. 5 times, or we could put it to the 5th power. So I'm going to do 0.83, and we're going to do this to the 5th power. So you get 0.3939. Everybody get how we got 0.3939? All right. So just remember, this is not the final answer because this is a probability none of them transfer out. But what we want to do, we want to find the probability at least one of them transfer out. So what we want to do, we want to use a complement rule because we want to find probability that X is greater than or equal to 1, which is equal to 1 minus probability that X is equal to 0. So we're going to do 1 minus 0.3. Oops. Let me get the eraser for that. 0.3939. And we'll get 1 minus 0.3939. And we get 0.6061. And that's it for A. Well, sorry, for B. So instead of finding probability of these 5 different outcomes, just find the probability of that one outcome, and you do 1 minus that outcome, and that will give you the probability of that occurring. All right. Everybody good for B? Cool. All right, so let's do C. So for C, if you look at C, it says, what are the probability that at least 1 of 10 randomly selected students from West Los Angeles College transfer out? So we still want to find the probability that X is greater than or equal to 1. The only thing that changed from B to C is how many people we randomly selected. So how many people did we randomly select now in part C?
10?
Yeah, 10. So what we're gonna do, we're gonna do 1 minus 0.83. And the 0.83, since we randomly selected 10 of them, you're going to put it to the 10th power. Any questions so far how I got the equation? All right, so I'm going to go ahead and solve it, and that'll be it for that one. There you go. 1
I have
minus.
a question.
What's up?
Oh wait, never mind. I got it.
Cool.
Oh wait, actually, 0.83 is who don't transfer out. So then we're putting it to the 10th power because it's like, well, only one of them out of the 10 is going to transfer out. So that's why. Oh, okay. I got it.
Yeah, because since we want to find at least one of them transfer out, so if I find the probability that none of them transfer out, since I know it should always add up,
shit.
since it always should add up to
Does it
one,
always should add up to 1?
Yeah.
so that's why you
So
put it,
that's why you put
so that way you put it.
Okay.
All right, and that's it for that problem. Any question for that problem? Sweet. So yeah, anytime you have the at least, pretty much it is saying that's the minimum, but it could be anything higher than that. And anytime you want to find at least one, you could always just use this,
Yeah.
where you do 1 minus the probability that x is equal to 0.
Right.
What if it wanted us to find out like at least 2? Is it a whole different thing we'll go over in the future, or is that like would we plug in 2 instead of 1 anywhere?
That's a good question. So for right now, based off of the tool that we have right now, we wouldn't be able to do that because we would be able to find the probability that x is equal to 0. So we could do that, but when we're trying to find the probability that x is equal to 1, when x is equal to 1, that means there are multiple outcomes. So you have to find the probability for all of those individual events and then add them up. So as of right now, we wouldn't be able to do this. Once we get to chapter 6, we'll be able to do problem like this. And this is actually called for binomial.
All right, thank you.
So yeah, so once we get to the binomial distribution, we'll be able to answer questions like this. But for right now, with the multiplication rule, you have to kind of keep it easy for right now. These are the type of problem you'll get. But yeah, good question. All right, so let me go here.